Your experiment, real-time task creation and deletion. So here we are going to create some task. Already I said task in the sense there will be some memory segment and there you will be having some program and data space, everything will be available. Okay, so that is called a task. Process and task are similar only. Okay, so here we are going to create a task. Okay, and then we are going to once after the work got completed, we are going to delete it. Okay, right? So if we are coming about real-time operating system, there are many real-time operating systems are available. That is free RTOS, that is one real-time operating system, and micro OS, that is another one real-time operating system, and your Android OS, that is also one kind of real-time operating system. Okay, so these are all some various real-time operating system which is available in market. Okay, so the Kale provides a real-time operating system that is called RTX51. Okay, the RTX51 is a real-time operating system which is provided by Kale software. Okay, right. So already I said there are some two types of RTX51 is available. One is RTX51 full version. Okay, in full version, we will be having all features, and in tiny OS, that is a kind of for educational purpose they have given this one. Okay, some limited feature will be available. So this one already I said, this is the difference between your RTX51 as well as RTX tiny. Okay, so then you can come here. These are all some various system calls. While coming about operating system, so we can use operating system with the help of system calls. Okay. So these are all some various system calls that is available for RTX51. Okay, so these are all some various system calls, right? So OS create, OS delete, OS send signal, OS clear signal. Okay, so already we are discussing some system calls for semaphore, mutex in your class, right? Okay, for mailbox, for task synchronization purpose. Okay, so for that we have discussed some various system calls, right? So these system calls that is used for your RTX51. Okay, so these are all some various system calls. Okay, so this system calls and its description is available in your PDF. Okay, then you can see now we will see how to create a task. Okay, now we will come to see how to create a task and what is the syntax for creating a task. Okay, right. So if we are coming about task, okay, if we are coming about task, so this is the syntax for your task. Okay, so here this is your return type. Okay, it is like similar like your function. Okay, your task will be written as a function. Okay, it is similar like your function. Okay, so the return type we are giving, so that is void, and this is the name of your task. Okay, so the function, the func is called as name of your task. Okay, so here it is not a function, it is a task. Okay, and this is the return type, this is the argument what we are going to pass to the task. So that one we are giving here, those are all arguments. And then here this keyword, this is a keyword, underscore task underscore, this is a keyword that is used that will treat this function as a task. Can you able to understand? Okay, this is until this void. Okay, until this point. Okay, that is until this point your until this point this is like normal function. Okay, and if you want to add, if you want to treat this function as a task, then what you have to do, you have to give this keyword. Okay, so this is the keyword, underscore task underscore, and number is the task number. Okay, so already we discussed about process, that it will be defined with the help of process ID. Okay, so we can define with the help of task number, right? So here it is given one simple task. Okay, so the purpose of the task is to increase the counter value. Okay, what is the purpose of this task? To increase the counter value. You just consider you have some normal clock. Okay, you have some normal clock, so that clock value I just want to increase for each and every time tick. Okay, so that is the purpose of this task. Okay, so you see here, so void job 0, this is the function name or task name. Okay, this is the task name, and here this is the keyword that is used to represent this function as a task, and here we are giving this as a task number. Okay, is it clear? So if I want to define a task, okay, I can define like this. Okay, right? This is the syntax we can follow for creating a task. Okay, and inside a task, how we are using a normal our C function that we used to write some statements. Okay, the same kind of statements we can able to write over here. Okay, so here while of one we are using. So while of one in the sense, as it is a embedded based application, we need to run our system continuously. So for that purpose we are using this while of one. Okay, so this is how we can define a task. Okay, this is how we can define a task. Then already we know for task management we have some different state. Okay, that process state and all we discussed in your class, right? So running state, ready state, waiting state, deleted state, and then timeout state. So these are all some 5 different state which is available for this task. Okay, so running in the sense whether if your task is running means that is running. Okay, that is it is in execution. If your task is in execution, then we can say is what? It is running. Okay, and ready means if the task is available with all data. If the task is available with all data, then we can say is what? Ready. And waiting in the sense if it is waiting for some event or some data. Okay, if it is waiting for event or data, then we can say is what? Waiting state. And once the task got completed its work, then we can delete it. Okay, because we have very less number of tasks, so we can delete once the task got completed. Okay, so then we can delete it. That means termination state. Okay, task termination state. Okay, so our task end, that is called your delete. Okay, and then timeout in the sense after some longer time period. We saw some different task synchronization. Okay, in that one is called starvation. Okay, starvation in the sense what? For a longer time period, it will not receive the data. So that is called starvation. Okay, so if any timeout event occurs, then we can go to timeout state. Okay, so like that we are having some different states. Okay, and then these are all other some functions which is used for some sending some signal. Okay, ISR, send signal, clear signal. So these signals and all we'll see later in coming experiments we can able to see. Okay, so now we'll see how to first let me tell you how to create a task and everything. Okay, so here you can see right directly I'll do the experiment. Okay, you also open your Keil software. All of you open your Keil software. So this is your Keil, right? So here you just go to this project. Okay, go to project and go to new vision project. Okay, go to project and go to new vision project. All of you open your Keil software and parallelly you do it. Go to project and create a new project. So just give one create one folder so that that will be easy for you. So let me create a folder with my VTU number. Okay, so let me create a folder with my VTU number. Okay, so just create a folder, and in that folder you just give your project name. So project name you just give us your VTU number. Project name you just give us your VTU number. So this number you can use it for all projects. Okay, for all experiment you can use the same one. Okay, so once you have created the project, you just go to this legacy device database. Go to legacy device database. So here you will be you can check generics. You can check generic. So in generic you just choose 8031 all variant. Okay, so generic 8031 all variant. Okay, and check these two button. Check these two button. Okay, use extended linker as well as use extended assembler. Check these two buttons and then click OK. Okay, check these two buttons and click OK. Then copy the startup file So that one also you just take it as okay. Okay. So like this in your project window, it will be available like this. Okay. Your project title and source group, your startup window like this, it will come. Okay. So here you just go to file, create a new file. So this is a new text file. Go to file, create a new text file. So there you just copy your code. Okay. So you have to type your code. So let me copy it. So here what we are going to do, we are going to create some 5 tasks and then we are going to delete it. Okay. We are going to create some 5 tasks and we are going to delete it. Okay. Now all of you listen here. So once you type your code, you just save that one. Go to file, save as. You just save it as .c. Okay. So this is a C file only. So you just save it as .c. So I am saving is at task underscore create .c. Okay. I am saving is at task underscore create .c. Okay. So this is what the color will be changed. You can be able to see here. Okay. So now directly let me go to the C function. Let me explain the code here. All of you listen here. Okay. The previous procedure and all already you have done. Okay, in the same microprocessor, microcontroller lab as well as the previous lab also talk in the sense, just unenroll and go out. Don't sit in my class. You sit here. Okay, listen here. So here we need to include some 2 header files. Okay. So those 2 header files are rtx51 tiny.x. Okay. Listen here. These 2, is it visible? The program is visible to everyone, right? Okay. So rtx51 tiny.h, okay, and then reg51.h. Okay. So this rtx51 tiny, that one will include the library files for rtx51 tiny operating system. Okay. Right. So this will include rtx51 tiny RTOS. Okay. So to include that one, so that is what rtx51 tiny function and defines. So everything will be included here. Okay. Then we are going to use some microcontroller 8051. So for that purpose, we need to include this reg51.h. Okay. So we need to include this reg51.h. Okay. Right. So here and then what we are going to do, we are going to create 5 tasks and then we are going to delete some 2 tasks after completion of its work. Okay. So we are going to create 5 tasks. Then after completion of some 2 task work, we are going to delete it. Okay, right? So so we'll see. So like your main function, okay, like your normal in C, it will be, your program will be started from main. Okay. In the same way, for this RTOS, your program will be started from this task 0. Okay. So whenever first your compiler will check where this underscore task underscore 0 is there. Okay. So that function will be treated as a main function. That task will be treated as what? Main function. Is it clear? Here in RTOS you don't have any main function. In normal C and all you'll be having what? So you'll be including the header file, then you'll be having what? Void main or int main, whatever it may be, you'll be giving. But in RTOS, you don't have any main function. Okay. So it will be checking your compiler, that is our cross compiler Kyle compiler. It will check this keyword underscore task underscore 0. Okay. So if that keyword is there, it will take that function as a main function. Okay. So here this job 0 is a main function. Okay. So already I said in this one, so this is the method to define a task. So we have to give the return type and name of your task, and this is the task keyword. Okay, the same way I have given what? Job 0 is the name of my task. Job 0 is the name of my task, and I am not going to pass any argument, so that's why I kept empty. Then this is my keyword. Okay, So from here one task I have created. Okay, so this is first task. Okay, our aim is to what? Our aim is what? We need to create 5 tasks. Okay, so this is my first task. The task 0 underscore task underscore 0 is my first task. Okay, so in my first task, okay, I'm going to create 4 more tasks. Okay, in my first task, okay, that is in task 0 function, I'm going to create what? 4 more tasks. So for that I'm using one system called OS underscore create underscore task. OS underscore create underscore task. So this is a system call. OS underscore create underscore task is a system call, and in this system call I'm giving one argument, that is a number I have given. Okay, so that number will be what? That is your task ID. Okay, so the task ID of this underscore task underscore 0, that is job 0 is what? The task ID of job 0 is 0. Okay, so already one task I have created. So in that task itself I'm going to create 4 more tasks. Okay, so with the help of this system call, okay, OS underscore create underscore task. Okay, and I'm giving some ID. Okay, so 1 and then 2, 3, 4. So like that I have created what? 4 tasks I have created. Okay, right. So 4 tasks I have created, and then the job of this first task is what? Just counting a variable called counter 0. I am going to increase the counter value, that is counter 0 value I am going to increase. I am going to increase a counter 0 value. Okay, right. So this is your job of your first task. So this is the job of your first task. So once this function got over, then we can then we can define second task. Okay, we can define second task. So this is my second task routine. Okay, so job 1, that is my name of my task, and then underscore task underscore 1. Okay, so this is the definition to define a task. Okay, and here that job of my task 2 is what? That is increasing the counter value 1. So here counter value 0 and here counter value 1. And about job 2 is what? Increasing the counter value 2. Okay, now job 3 is what? That is job 3. I am going to send some data to a port of 8051. Okay, I am going to send some data. So that is hexadecimal data. That is why I have kept what? 0xAA. Okay, 0xAA in the sense what? So 0xAA in the sense that is 1010 1010. So that is called 0xAA. Okay, so this is in binary format. Okay, so in binary, that is 0xAA in the sense 1010 1010. Okay, right. So this is my job of this job 3. Okay, this is my job of my job 3. Okay, is it clear? And once this job got completed, let me take this port 0. I have connected some LED. I want to display some data to the port 0. So once the display got completed, I am going to delete the task with the help of another one system called OS underscore delete task. Okay, so OS underscore create task will be used to create a task. Okay, and if I want to delete in the sense what? OS underscore delete underscore task, and which task I am going to delete. Okay, so that task identifier, task ID I need to give in the argument. Okay, is it clear? Okay, the task ID I need to give. Okay, so this is for job 3. And about job 4, I am going to send some data to port 1. Okay, I am going to send some data to port 1. 88 in the sense what? 88 in the sense that is 1000 1000. So that is 88, right? So this data I am going to send to port 1. So once after completion of this one, I am going to delete it. Okay, right? So these three tasks that will be continuously running. Okay. So these three tasks that will be continuously running. That is job 0. So this job 0, job 1, job 2, that will be continuously running, and job 3 and 4 will be deleted once after completion of its work. Is it clear? Job 0, job 1, job 2 will be continuously running. We are creating 5 tasks. In that 0, 1, 2 will be continuously running, and 3 and 4 will be deleted once after completion of its work. Okay, so that is what our program. Okay, is it clear? Any doubt in this? Any doubt? Okay, right. So once you have completed your programming, then you just save this file. Okay, so already I said you need to save it as .c. You need to save it as .c. So you can able to see here task underscore create .c. So this is my file. Okay. So now here, before going to compile your code, okay, just go to this project, and here you can see options for target. You can see options for target. So just click on this, and you choose operating system as RTX 51 Tiny. You choose operating system as what? RTX 51 Tiny. If it is none, in the sense it will treat as a normal C program. Okay, if we are choosing as RTX 51 Tiny, that is what our program. Okay, and RTX 51 full, in the sense that is your full version. Okay, so we are choosing RTX 51 Tiny. Okay, then you just click OK. Then you go to project, rebuild all target files. Rebuild all target files. Okay. Before that, you have to do one thing. Just click or right click on source group, add existing files. So you just add your C file. Okay, you just add your C file. Okay, and it will be there is some warning. Just leave it, that warning. That is you have to give some return type. Just leave it, no issue. Okay, so 0 errors and 2 warnings. Okay, so go to project, then rebuild, build all target. You will be getting your, if any error is there, that error will come. Okay, right? So if there is no error, okay, you can go to debug session. So go to debug, start or stop debug. Go to debug, start or stop debug. So in debug, okay, so in debug you need to open 3 windows. One is, that is in debug you can able to see OS support. In debug you can able to see OS support, and then in debug, in peripherals we need 2 ports, that is port 0, and then in peripherals port 1, port 0 and port 1. Okay, right, port 0 and port 1, and then we have some variable here, that is counter 0, counter 1, counter 2. So to check the change of counter 0, counter 1, counter 2, go to view, go to watch window, watch 1. Okay, go to watch window, watch 1. So here you give the name of the variable, that is counter 0, that is my name of my variable. Just give that one, and then counter 1, then counter 2. Okay, right? So these 4 options you need to choose. You need to choose to view the output. Okay. So in the PDF itself I have given. You can able to check here. So once you type the code, you go to menu, peripherals, IO port, select port 0, port 1, and menu, view, watch window, enter variable 1, variable counter 0, counter 1 and counter 2, and menu, debug, OS. So these 3 you have to do. Okay, so once you do this one, you will be getting like this. Okay, so now you see here there are some 5 job as created. Okay, job 0, job 1, job 2, job 3 and job 4, and its identifier also given. Okay, task identifier also given. The state is what? Deleted state, which is still not yet started. Okay, still not yet started. And here the timer, everything is 0, and the port 0 value is high and port 1 value is high, counter value is 0. Okay, right? So now let me run this code, go to project, go to debug, run. So you can able to see here the program is running. So you can able to see here, that is the job 0 is running, job 1 isn't ready, other jobs got created. So you can see here